Back to Who Wants to Be a Mathematician. I'm still your host, Mr. Hill, coming at you with some AP Calculus. This is 4.x1, dealing with acceleration and some velocity stuff. And this is going to be part 2. We're going to do example 4 and 5. So example 4, we have a lovely car. A nice little car here. See, this is the car right here. Car. And an accident happened. The car traveled 196 feet after he slammed on the brakes until the car stopped into the tree. Assuming that the car decelerated at 8 feet per second squared, how fast was it going when the brakes were applied? Well, we have our position equation right over here, and we know that the final position is this part here. We know that S naught is our initial position. V naught stands for initial velocity, and A stands for our acceleration. So we're just going to start plugging in some information that we know. Don't mind the cat. So we know our S of t, which is our final, is 196 feet. It traveled 196 feet. We know that our initial position, we're going to say this is ground 0. So we start at 0 and we end up at 196. We know that our acceleration is decelerating, so that means we're negative 8. And our velocity, oh, well, that's what we're trying to find. So now let's plug in our information that we know. So we have, we have 196 is equal to 1/2 times our negative 8t squared plus our v naught t plus our s naught. So we have 196 is equal to negative 4t squared plus v naught t. And now we just need to solve for v. But the problem is we have two variables here, so we need to figure out a different equation. Well, do we know anything else? Not really. But given that this is calculus and everything we've been doing is with derivatives, we can look at our derivative function. We know that derivatives deals with acceleration. So since we're trying to find our initial acceleration, maybe that's something good to look at. So we'll look at our initial acceleration. We take the derivative, and we get at plus v naught. We just distribute, we bring down our 2 times our 1/2 gives us that, derivative of that is v naught. And now let's plug in what we know. This is going to be our initial velocity. Do we know our initial velocity? No. So that's what we're looking for. This is our velocity. And then our acceleration we know is negative 8. And this is going to be our, just kidding. Come on. This is our final velocity. And we know our final velocity to be 0 because we ran into a tree. So 0 plus our velocity initial. So we know that v naught is equal to 8t. Well, then we can just come back over to our other equation and plug it in. So we have 196 is equal to negative 4t squared plus 8t times t. So I have 196 equals negative 4t squared plus 8t squared. So I have 4t squared. And now t squared is equal to 49, so that must mean that t is equal to 7. Well, we have our time it takes for us to go from starting to final, and to get our velocity we just need to plug it in over here, and we get, up you go, oh man, our v naught is equal to 56 feet per second. Ta-da! So now let's look at example 5. Scroll down. Now we're in free fall. And free fall means that we are falling. So we know that we have some dude, and maybe he has like a potato cannon or something, and it fires some object up with the initial velocity. So we have initial velocity is 400 feet per second. Well, from our very front of the page we have our equation. So we have our position is given to us. If you flip over to the front in free fall, which is 1/2 gt squared plus v naught t plus s naught. And the reason why this equation is different from our other one is because in free fall, our acceleration, the thing that's dealing on us, is gravity. We're not moving left, we're not moving right, we're just free falling, so that's why our acceleration changed to gravity. And since over here we have feet per second, we're going to use the gravity, which is our negative 32 feet per second. So now that we've dealt with our knowns, let's see what the problem asks. A says, find the equation of the distance. We just need to plug in our stuff and see what we get. So our equation is this. We have 1/2 times negative 32 t squared plus 400 t. And our starting position, if we think about it, is on the ground. So our starting position is 0. Nice. That was relatively painless. So B, find the time duration. So find time at which and velocity at which it hits the ground. So it says find the time when it hits the ground. Well, when it hits the ground, we know the final position is going to be 0 because, well, if you start on the ground and it hits the ground, then it's 0, and then that's 0. So 0. So then we have negative 16 t squared plus 400 t. And then we just need to solve for t. So 0 is equal, we can factor one of these guys out. And we have either t is equal to 0, or we have 16t is equal to 400. Divide both sides by 4. I get 4 and 100. Divide again by 4. I get 4 and 25. So t is equal to 25. Now, it says when it hits the ground, and our time at 0 is when we start. It's not when we hit the ground. So really, we're looking for 25. So that's our time. And it also asks, what is the velocity? So we know that our velocity is equal to the derivative of our position. So we're just going to take the derivative of that guy. Let me just scroll up. There we go. So we're going to get negative 32t plus 400 is equal to our velocity. And what we know, time is 25. So we just plug it in, and we're going to get our velocity is equal to negative 800 plus 400. So that means we have a negative 400, is it meters, feet? What are we dealing with? Feet per second. Nice! So now we have to find the maximum. Ooh, the maximum altitude achieved. So altitude is how high, so it starts here, lands over here. So we're looking for the maximum. And we know maximums are when our derivative is equal to 0. So we just look at our derivative. We have 0 is equal to negative 32t plus 400. So that means we have time is equal to 400 over 32. So that's our time at which we're at the maximum. So this is when t is equal to 400 over 32. So if we clean this up, we're going to get, so this is 100 over 4? 4 times, nope, just kidding. 4 times 8. 16, yeah. Which means we are 25 over 2. So we are at 12.5. So that's our time. So we found our time, so now we have to find the maximum altitude. So we have to find our position when we're at 12.5. So we just plug that in, and we get negative, what was it, 16t squared plus 400t. And we just plug that in, so we get negative 16 12.5 squared plus 400 times 12.5. We pull out our nifty-difty calculator. That's behind me. And we're doing it, and we're doing it. Okay. So we have 12.5, come on, 12.5 squared times negative 16. So this first part is negative 2500 plus 400 times 12.5. And this is 5,000. So that means our final position is 2,500, or our altitude, the highest point going up. This distance here is going to be 2,500 feet. Bada bing, bada boom, and we're done.